Frank, in your famous formula that has your name, the Drake equation, we come up with a range of intelligent civilizations in the universe. It's sometimes a broad range, but there seems to be quite a number of them as you deal with all of these factors. The question that some ask is that if there are all these civilizations, why don't we see evidence for it? Whether visitations on Earth, notwithstanding some of the artificial UFO stuff, but real evidence. And looking out at the universe, we don't see any evidence. Does that contradict?
That's one of the big questions in this whole subject. It was actually expressed best by Enrico Fermi many years ago, who thought through this whole picture. In fact, in a way, he had in his head the Drake equation when he did it. And he said, where are they? Why haven't they come and visited us? There must have been millions of civilizations. Why aren't there relics here on Earth? Why aren't there ambassadors? Why aren't there bright neon signs in the sky? This is called the Fermi paradox, that everything we know says there should be many civilizations, but then we look to space and we don't see signs of it. We don't find artifacts here on Earth. So what's the answer to this? Lots of answers have been presented. One of them is that, oh yes, they're on their way, but they just haven't gotten here yet. That's a favorite response. Another is that they find us fascinating, in fact entertaining, and so they've declared that we're a nature preserve. And if we but knew it, there are the equivalent of Gray Line buses hovering overhead, full of space tourists laughing their heads off at the antics of the creatures down there on that place we call planet Earth. But they want to keep this a preserve so they don't reveal their presence. Well, that's kind of far-fetched. It's called the zoo hypothesis, but it's out there. My own answer to this is that we have been, in a way, misled by science fiction, where you dial up Scotty and say warp 7 and you go from one star to the next in the time it takes to give a commercial. Well, the universe isn't that way. It is a great distance between the stars, and the time for travel between the stars is enormous. Even the nearest star takes 4 years to reach at the speed of light, and there's no spacecraft that's going to go the speed of light. Our present spacecraft go at 1/30,000th the speed of light. It takes us, with present spacecraft, hundreds of thousands of years to go the distance to the nearest star. So when you talk about traveling to other planets, which science fiction has suggested will be easy in the future, it turns out physics makes it so that really isn't so. Take an example, a reasonable example. Say we wanted to go to one of the nearest habitable stars 10 light years away. There are planets like the Earth about that, or stars like the Sun, probably with planets like the Earth, that close. Suppose you wanted to go there at 1/10 the speed of light. It would take you 100 years to get there. It would take enormous amounts of energy. You need to work that out. If you imagine the spacecraft as the size of a small airliner, it's going to have 100 passengers. This is a reasonable mission. It's going to take 100 years to get there. Most of the passengers will not live to reach the destination. It's a very hazardous adventure because if you impact even a tiny pebble, it will demolish the spacecraft.
Going at that speed?
Going at that speed. Because if you encounter a small pebble, the energy released when you hit it is more than you get if you use that in a nuclear reactor for energy. It becomes like a nuclear bomb. It destroys you. One pebble. Would you really want to spend 100 years traveling in a cramped spacecraft watching the same movies over and over? You know, it's not an appealing picture, and it's even much worse than what I just said. Because the amount of energy required, no matter what your propulsion system is, you work it out, is equivalent to 200 years of the total electric power production in the United States. In other words, you have to shut down America for 200 years to launch this mission, which is never going to come back. Huge amounts of energy are required to go at high speed in interstellar travel. Amounts of energy which any intelligent civilization would realize can be used to much better purpose in their own system. In fact, you can colonize your system for a millionth the cost and energy of flying to another star. So my answer to the Fermi paradox is, well, there are two answers. One is an intelligent civilization would not attempt interstellar space flight. Only the dumb ones would, and they don't know how to do it. And the other answer is there's no need, because what we want to gather is information, and we can do that at the speed of light with radio and light waves at much less cost.
There's another idea that so-called von Neumann probes, which are non-human probes that are sent out that are self-replicating, and they would go to a planet small. They don't need to take oxygen along or whatever the aliens breathe, and then they can replicate themselves and then send 2 or 3 to others, and so that they can spread exponentially. And some people have calculated that even if you assume it's 1,000,000 years to go from star to star, I mean a long period of time, you only need 40 generations of this multiplication to be able to fill the whole galaxy, because you have this exponential growth in 40 generations. And so 40 million years is really trivial in terms of the age of the galaxy. So it would not be difficult for a civilization modestly beyond our own to send out such probes.
Yes, that's all correct. In 40 million years, you could colonize every star in the galaxy with self-reproducing probes. You ask a question, why would you do this? What benefit is it to you? That's one question. A second worry is the probes will turn on you, and they will become vicious aggressors. And here you've seeded the whole galaxy with them. You haven't got a chance if that happens. And the other thought that goes with those is just sit down and try to design one of these things. It's gone across space, it enters a planetary system, it has to make a reconnaissance, pick out a planet that's suitable for its reproduction, go through all kinds of exotic maneuvers to soft land on the planet. It lands, where does it land? Maybe it lands in the ocean, maybe it lands in the Sahara Desert. And now this thing's going to start with nothing but dirty sand and make transistors and rocket engines and little computers, big computers. You can say that in principle this could be done, but if you really tried to do it, I think you'd find out something would go wrong.
Well, these kinds of thought experiments don't require huge numbers. They just require one in a galaxy, and that's an interesting factor, that you just need one that doesn't subscribe to the logical way of doing things or being able to be successful.
Yeah, I call that the cancer hypothesis. It's just like cancer. It's a bad thing, but it only takes one malignant cell to populate the organism, in this case the galaxy. Well, it hasn't happened as far as we know, and maybe it's because all the intelligent creatures are wise enough to realize it's not a good thing to do, or it can be that space is much more hazardous. Space travel in interstellar space is much more hazardous than we realize, and that if we really tried this technique, we would find out that all of our little spacecraft get destroyed somewhere along the way before they ever get somewhere useful.
The hypothesis that, for whatever reason, our civilization is indeed the only intelligent civilization in our universe, is that something that you would consider?
I would consider it for about 2 seconds. I think it's preposterous. There's nothing special about our solar system. If you came to the Milky Way galaxy and looked for an interesting star to visit, you wouldn't come to the sun. The sun is the most average star in temperature, age, chemical composition, Nothing happens with the sun. It doesn't vary much. It has a few sunspots. Boring, boring, boring. It's boring until you get close enough and you say, hey, look, there's that blue planet. And if you look closer, oh, hey, there's chlorophyll on it. And if you look real close, you see super highways and airplanes flying around. But our sun is a totally boring place. Nothing special about it, which tells me that what happened here must have happened in many, many places. And given that there are 10,000 million stars in the universe, it's preposterous that there aren't other intelligent creatures.